Hi girls, I hope that studying for the semi-test is going well. I found this problem that I thought would be really helpful for you to practice with as you're studying. And so I went ahead and made a screencast, or I'm making a screencast, of the solution to this problem. Because I know that many of you, in working through these problems, may have, you know, little questions here and there. So I thought it would be nice for you to have something, a recording of me working through the entire problem that you can play and pause as you need and repeat as many times as you need. My suggestion for you would be to pause this and go ahead and work through the entire problem. When you finish with the problem, play it and listen to what I say and make sure that your answers match up to what I do. Also, make sure you pay attention to the little nuances in the problem, such as the pluses and minuses and quadrants and all those little things that all piece together for the solution of these problems. I know these problems can be all-encompassing at times, and it can be hard to remember all the little things that you need to do to get through the problem successfully. So anyway, I hope this helps, but at this point I would go ahead and pause this problem, work through it, and then when you're finished, go ahead and replay. Okay, so in looking at this problem, we see that we have alpha and beta, and we also see that in A, B, and C we're asked to use the alpha and beta to find the cosine of its sum, the cosine of double beta, and then later on the sine of beta over 2. So what we need to do first is go ahead and determine our triangles, figure out what alpha and beta are. So let's first look at alpha, and we see that alpha is between negative pi over 2 and 0. So that's going to place alpha in quadrant 4. So for my triangle in quadrant 4, this is alpha, and we know that its sine value is negative 4/5. So with negative 4/5 sine value, our opposite is going to be negative 4, our hypotenuse is going to be 5. Looking at this triangle, we see that it's a 3, 4, 5 triangle, so we know our adjacent has to be 3. Okay. And remember that this is in quadrant 4 because negative pi over 2 is the same thing as 3 pi over 2. So alpha is going to be between negative pi over 2 and 0, or 3 pi over 2 and 2 pi. That's quadrant 4. Now we're going to look at beta. Beta is going to be between pi over 2 and pi. So that's going to put beta in quadrant 2. So draw our triangle in quadrant 2, and we see that its cosine value is negative 5 over 13. So this is our angle beta. Our adjacent is going to be negative 5, and our hypotenuse is going to be 13. And again, this is, I don't know how many of you have noticed, but this is that other special triangle. It's a 5, 12, 13. So we know that the y value is 12. If you don't know these triangles, remember you can always just use the Pythagorean theorem to find any side lengths. So now that we have our alpha and beta triangles drawn, we can start applying our identities from our identity sheet to solve these problems. So for A, it says that we need to find the cosine of alpha plus beta. So what I would do first is go to my identity sheet and identify the alpha plus beta identity. The cosine of alpha plus beta is the same thing as the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. Remember, you will be given these formulas. You'll be given the formula sheet for the test. No need to memorize these, but you want to make sure that you can recognize them and make use of them. Okay, so to find the cosine of alpha, we look at our alpha triangle. The cosine of alpha is going to be adjacent over hypotenuse, or x over r, which is going to be 3/5. Cosine of beta is going to be x over r in our beta triangle, our blue triangle, which is going to be negative 5 over 13. Oops. Then we have minus sine alpha. The sine of alpha is going to be opposite over hypotenuse, or y over r, which is going to be negative 4 over 5. And then the sine of beta, which is going to be opposite over hypotenuse, the blue triangle, which is going to be 12 over 13. Also, do you notice that I'm making use of the signs, the S-I-G-N-S, on these triangles? Make sure when you have a positive or a negative sine or cosine value that you appropriately put the sign where it needs to be. And remember, the sign is determined by the quadrant. So for the red triangle, since it's in quadrant 4, the y value has to be negative. The x value is positive. For the blue one, it's in quadrant 2, so the x value would be negative. The y value would be positive. That makes a big difference. Okay, so now we just use our calculators to multiply across. So negative 5 times 3 is negative 15. 13 times 5 is 65. Minus, this is going to be negative 48 over 65. So this is going to be negative 15 over 65 plus 48 over 65. And we get 33 over 65. That is our final answer. That is the cosine of alpha plus beta. Okay, so now moving on to cosine of 2 beta. Cosine of 2 beta, we look to the double angle identities, and we remember that double angle identities, the cosine double angle identities, we have 3 different formulas to choose from, and it's really a matter of preference of which one you choose. You'll get the same answer no matter which one you do, as long as you do them correctly. So if we choose, I'm going to just arbitrarily choose cosine 2 beta is going to be 2 cosine squared beta minus 1. So what I'm going to do is I'm going to plug in cosine of beta into this identity to get the cosine of 2 beta. So this is going to be 2 times the cosine of beta, which is going to be negative 5 over 13 squared minus 1. And I'm going to simplify that, so that's going to be 2 times 25 over 13 squared is 169, I think. Minus 1. So then this is going to be 2 times 25 gives me 50 over 169 minus 1. So now I'm going to get a common denominator. So this is going to be 50 over 169 minus 169 over 169, which is negative 119 over 169. And that is my final answer. That is the cosine of 2 beta. Okay, and then lastly, I want to find the sine of beta over 2. So, the sine of beta over 2, I'm going to go to the sine. Okay, something happened there and it stopped recording. I'm now going to the sine beta over 2 formula. And the sine beta over 2 formula is plus or minus square root 1 minus cosine u divided by 2. So, what I need to do is plus or minus square root 1 minus the cosine of u is negative 5 over 13. Or cosine of beta is negative 5 over 13. So this is going to be 1 minus negative 5 over 13 over 2. Simplifies to 1 plus 5 over 13 over 2 plus or minus square root 13 over 13 plus 5 over 13 divided by 2. So So this is going to be plus or minus square root 18 over 13 divided by 2, which is plus or minus square root 18 over 13 times 1/2, which is plus or minus square root 18 over 13 times 2, which is 26. So now we get plus or minus square root, well, okay. Draw flat. Square root of 18 over the square root of 26. We want to try to simplify each radical. So this is going to be 18, 6 and 3, 2 and 3. So this is going to be plus or minus 3 root 2 over root 26. And then 26 doesn't reduce because 26 is 13 and 2. So, do you see that we have 3 root 2 over 26? So this can be plus or minus 3 root 2 over root 26. And we can put root 2 and root 26 under the same radical. So this is plus or minus 3 times the square root of 2 over 26, which is 3 times the square root of 1 over 13, which is 3 over root 13, which simplifies to be 3 root 13 over 13, plus or minus. Okay, I know that was a lot of algebraic manipulation there. But our final step here now is to determine whether or not beta over 2 is going to be positive or negative. And remember, we determine that by looking at where beta is. Beta is in quadrant 2. So if beta is in quadrant 2, beta over 2 has to be in quadrant 1. Wherever that angle beta is, somewhere in quadrant 2, if you divide it by 2, you would land in quadrant 1. So beta over 2 is in quadrant 1. And in quadrant 1, beta is, or the cosine value is, in quadrant 1, cosine is positive. Therefore, this answer is going to be positive 3 root 13 over 13. And that is the solution to this problem. I hope this worked out for you. And don't worry so much about the algebraic manipulation at the very end of this. I'll accept a variety of solutions, or solutions as long as it's simplified. So I hope this helped, and good luck with studying. Thanks.